Thank you very much. We do not have donuts, but we do have a lunar lander. So come and check that out. We all know these numbers, so I'm not going to bore you with these. World demands more. We're trying to find huge amounts of critical minerals really, really fast. Can't do it. Don't have, we need some sort of crazy technological breakthrough if we're going to actually meet net zero targets. It's extremely, extremely hard. $13 trillion opportunity that keeps our investors really excited, but it's just a big number. How do we actually get there? The job's getting more difficult. I was talking to a geologist in Peru a little while ago, and they were saying, well, you know, it is 1 in 500 holes actually kind of hit something in exploration. That's 10 times worse than 10 times worse than just playing roulette with $1 million bets. And playing roulette with $1 million bets sounds like something I really want to try. So, you know, that sounds a lot more fun than being out in the desert drilling random holes. But it is a really, really hard challenge. So we talk about, in the last, I was on a panel discussion just a moment ago, and we're kind of talking about, like, what is happening to this industry? Like, what is this weird feeling? Why is there a weird space company talking to you? I'm sorry. I kind of like, we're here. It's happening. We talk about this being a new era, but this is not just us. This is everything that's going on in the industry. In the 70s, you kind of had this approach where it was, hey, still about getting lucky, basically. Finding something new was stumbling on it, seeing some nice green rocks sticking out. In the 90s, we moved to more geophysics and consulting. In the 2010s, everyone was told, store all of your data. Most of the people telling you that were people working for Jeff Bezos. Just store it all, and maybe one day it'll be magically super, super valuable to you. And now everyone's kind of sitting there going, all right, we stored all the data, and now we want to unlock it, and we might have access to maybe 10% of what we've stored. We're still paying big fees to the hyperscalers to keep it. We hope that it's going to be worth billions of dollars, and we hope that AI and things like this age of intelligence is going to unlock it. And I think that is true. It's just really, really fucking hard. Sorry. So these are all the technologies coming online, right? I won't read all these, but it's like, these are the kind of hallmarks of what this industry is going for: real-time data, data-driven drilling, data-driven decision-making, like our friends at Schneider are talking about. That's all true. That's all the stuff that we need. And adaptive companies are adopting these things, again, really hard. The old playbook can't win the game. We typically make those decisions. It should be a control loop. It should be a loop. We like loops. But it is typically this really fragmented, linear process. We still end up with a lot of data in silos, and then we tend to make decisions on a seasonal basis. Because sometimes, I mean, some of our tier 1 customers are saying, well, we're trying to do all this, but we've got 26 different vendors that are trying to do the baton race. Like, okay, the data's being generated, then it goes over here, it gets processed, then it comes back, we integrate it with everything else. And if anyone drops one of the baton handovers, you're back to making a decision on an annual cycle and deciding where your exploration dollars go or your resource expansion dollars go, you know, on an annual basis. That sucks. We like to think about, like, what is happening? Like, what does it look like? And, you know, Cobalt, slightly controversial. Frenemies in AI exploration, right? There, maybe this is the story that AI in exploration was looking for. Maybe this is that story, maybe not. But I think it's interesting seeing a junior raising money like a Silicon Valley tech company, raising from the biggest billionaires in Silicon Valley. That's interesting. And hats off to them. Like, we should be seeing more of that happening. And like I was saying earlier, it is like there's a lot of Silicon Valley money now looking at mining going, where do we get involved? Technology, into the juniors, directly, you know, all that kind of stuff. We like examples like Rio Tinto's Mine of the Future. I mean, this is a roadmap that was implemented, you know, long-term robotics roadmap, 20-year vision, implemented well, working, and now they're working on the next roadmap, right? So we like that it actually got done, large-scale automation. And then, you know, friends like Oz Minerals got absorbed by BHP, but a lot of the ideas that we talk about today, we recognize they started it there, basically. People saying, hey, we want to do generative exploration. We've got 169,000 gravity anomalies in South Australia. How do we choose where to drill? Basic questions, but like, what new technology are we what new data set are we gonna add to this to start knocking out some of these targets faster? So they managed to cut exploration cycles really, really fast, and then got absorbed by BHP. And it would have been interesting to see where the Oz Minerals story would have gone. But I think now a lot of those principles are moving into BHP itself, and hopefully we see this wave kind of keep coming through the industry. So future leaders are adaptive. I think that's kind of clear. We all know we need to adapt or die. That's clear. And then it becomes about how, because it is hard, and we get it. And I like the approach, like Schneider laying it all out there. It is hard. There are a lot of bubbles. There are a lot of things that have to connect. There's a lot of workflow automation and a lot of aspirations about where we want to get, but it is hard. So how do we enshrine that into practice, from exploration to expansion, from today's mines to tomorrow's frontiers? And the frontiers we're talking about are very far frontiers. We talk about from the Earth to the Moon and Mars and beyond. So we talk about this trend that we're all living as Agile Geoscience. We're basically just giving a word to what we see in the industry. It's not us doing it. It's everyone out there is starting to adopt a new philosophy, basically. So we wanted to kind of codify what is it that we're actually talking about, so that we're using the same language when we're talking to each other. And again, like I was saying a little bit earlier at another talk, what we saw was the software industry adopting agile software development and changed the way products were built online. We're all like, yeah, well, that's software. That's not really hard problems. That's just software engineers having fun and throwing stuff against the wall and seeing what sticks. But then those software billionaires moved into aerospace and transformed a decades old, extremely old government space industry with software and agile software development practices, building rockets like they built software, blowing a lot of things up. And we're now all kind of fine with seeing daily rocket explosions on TV going, yeah, that's progress, that's good. That's what it should feel like. That would horrify people 20, 30 years ago in the space industry. But it is actually how you get progress. It's about failing fast. So Agile Geoscience now, I can tell you, someone asked me, it was Tristan at First Quantum in London a couple of weeks ago, was saying, wonder what Amazon would do in exploration. How would they think about this? And I said, I can tell you exactly what Jeff Bezos is doing. He's putting $1 billion drill on the moon for NASA and starting to look for water ice. It's an interesting kind of thing. And it turns out these aerospace billionaires are now getting very interested in rocks. And that's why space companies are now here talking to you guys, because whether it's asteroids, the moon, Mars, or Earth, it's all rocks, basically. And we're bringing a lot of aerospace engineers, a lot of satellite engineers on our team, bringing them to solve problems around sensing on Earth and unlocking some of these challenges with data transfer. And it's really cool. Like, we keep them in a room, we slide pizza under the door, we feed them a lot of Red Bull, and we just throw really, really hard, intractable problems that people have been struggling to solve for decades at these guys, and they don't talk to us very much, but they work it out. It's amazing. So introducing Agile Geoscience is the point. Velocity, integration, and adaptation. And the first one, I think, is we really focus on that. Fleet means fast. It's about speed. And the measure of success here should be how fast are you moving in general. Velocity captures value, right? So on the left side of this slide, it's a lot of X's in red, right? What we want is if you can turn over the card, understand what you've got in real time, if you can make that decision-making loop close today, not 3 months or 6 months from now, where you're reading a report making your next decision, if you can make your decision now about where to drill, you should move towards the right of the slide, right? More green things, basically. It's kind of like playing, we talk about playing battleships, but what happens if you get 2 or 3 moves to your opponent's 1? Speed matters. And a lot of people said to us at the beginning, well, the rocks aren't going anywhere, why should I care? But if you've mobilized equipment out to a site, and while it's there, you can take the next decision, drill the next hole, or stop drilling something that you're already drilling, that's money. That's easy savings, easy wins. But typically, we let programs run. They run out, team comes back, they get the data kind of asynchronously, maybe they do some geophysics, look at that 6 months later. We say it's like, doing it that way is kind of like getting an ultrasound on a pregnant belly and looking at the picture 12 months from now. It's academically interesting, it's good training data for an AI one day, but it's not actually helpful right now. So we want to do the same thing with exploration. So velocity captures value beyond the training data. We want operational value. This is not rocket science, by the way. Integration builds confidence. Like, this is not a revolution. We know this. It's just about how do you do it. So bringing all data together reduces uncertainty and strengthens decisions. Can you be doing that in real time is the key. And adaptation delivers success. So fast, integrated decision making, it's pretty obvious, right? I'm not telling you anything you don't already know. And I think that's probably frustrating. I can see people looking at me going, yeah, I get it. We're trying, we're really trying. This is really hard. So again, concepts that we talk about, new data acquisition, and then we talk about the data well. I think this is something that we need to talk about. We need a new term for this because your data lake is a mess. I'm sorry. Like, in general, what we discover is like 90% of it is unusable. And we all know, like, it's unusable for a range of reasons. We need to cleanse it. We know that. That's going to take time and money. So what is cleansed and usable, that is your data well. I think that's a good concept for us to talk about. You want to get more stuff into the data well over time, and you want anything new that you're generating from the field to go straight into the data well. You don't want to spend another 12 months messing with it and fixing it until it's ready to kind of be integrated with the rest of your data. You should use your data immediately, and the longer you don't use it, the harder it gets to use it. So we should expect speed. So we're doing wild things at the moment. We've got some of the largest exploration surveys on the planet going on right now. Just surveyed 12,000 square kilometers in 3 dimensions in Saudi Arabia. A lot more to come. There's a lot of mineral endowment there to unlock. I mean, that's pure green fields, and there's a lot of it, and that's something we do really, really well. But acquiring new data in the way we're going to use it is the key. This is the key. Ensure only clean, consistent data flows into the data well. It's really no good if you need to hire a bunch of people from Accenture, sorry Accenture, we love you, to fix it. You should create it and use it immediately, and it should be clean when it goes in. It should be clean when you create it, which is why we built our own sensors, because we didn't want to leave anything to chance. Multi-physics integration, no silver bullets in this game. Would love it if there was, but there really aren't. This is about stacking data quickly, right? So generating lots of different data sets together, at least 2, and then bringing them together with drilling data as fast as possible. Very key. And then predict, right? Like, that's what we want. That's what we're all asking for in this industry, is like, AI is going to help us predict, make better decisions, at least help us ask the right questions, if not giving us the answers. And this is it, right? Like, how do we reduce drilling costs? We're seeing this happen again and again and again. It's not really reduced drilling costs at the end of the day, is it? Like, we're still going to drill more. We're going to drill all the holes we possibly can, but we want more shots on goal and better decisions to be made. And so that's it. Like, that's what we talk about as Agile Geoscience. This is not, I'm not telling you anything new. I'm just giving language to what we see happening and this change that's happening. Same change that happened in software development, same change that happened in our industry in space, and now it's here, right? It's already here. People are already doing this. It's just a matter of how fast can you do it and who's going to help you get there. But the adaptation piece is what we're trying to get to. And this loop, whether it's a control loop or whatever, it's a decision-making loop, this needs to close. I mean, nirvana is hourly, right? At the moment we see it's months or years. This loop needs to close, I mean, we see customers getting it down to weeks, and that's revolutionary. If you can get it down to days or hours, that's perfect. And that's it. Velocity, integration, adaptation. I love this slide. This is how we freak out people at NASA. But this is what we're training for. I mean, that lunar lander out there is a one-to-one mock-up of the Firefly Blue Ghost lander. It's landing on the moon next year, and it will deploy some of our sensors. The first Australian thing to touch the surface of the moon. It's a pretty proud moment. And we're going to de-risk some of those billion-dollar drilling programs and those exploration programs on the moon. We're going out to asteroids, we're going out to Mars. And for us, all of this is just training for what comes next. And we figure, you know, if it's kind of more and more my life is the plot of Armageddon, like we need to go out and Bruce Willis some asteroids, it's probably going to be an Australian team that does it. So we're excited about honing those skills and doing what we do best on other worlds. So come and chat to us. We're a lot of fun. No donuts, but we got the moon. Thank you.